Hello, this is Dr. Mears, and we are going to be transforming between exponential and logarithmic equations. So first, logarithmic equation, log base A of C equals B. Exponential, A to the B equals C. Let's label these, logarithmic, exponential. Okay, so let's go from log to exponential, right? Log base 7 of x equals 2. Now notice I said base because here A is the base and A is the base. To easily transform this, I'm going to show you a trick. We have base A, so you're going to write down, here we have base 7. You're going to raise that to the power of B. So you're going to raise 7 to the power of 2. That is going to equal C, x. So 7 squared equals x. That's how you transform it. Use my circle method. It works every time. You could take this farther if you wanted to say 49 equals x. I might have you solve for x. That's fine. Right now, I'm just asking you to write it in exponential form, so stopping there would be fine. However, a simplified version is 49 equals x. Number 2, write log base x of 6 equals 3. So here we have our x. That's our base, x, raised to the power of 3 equals 6. Again, I'm just asking you to write an exponential form. I'm not asking you to solve it. I just want you to transform between log to exponential. That's it. All right, let's go the other way. Let's go from exponential back to logarithmic. And yes, very similar to what you were doing. First, we have to write 5 squared equals 25 in logarithmic form. First, write your log. Okay. Now, the little tiny number, this is your base. This big number is your base. So here, what's our base? Our 5 is our base, so that's going to be our little tiny number. So 5, what are we taking the logarithm of? 25. What is that going to equal? Equals our exponent of 2. So you're just going around in a circle. Log of base 5, 25, 2. Let's do this one. Log, we need 4 to the x equals 64 in logarithmic form. Write down the log. Okay, what's the base? What's that smaller number going to be? You got it, 4. What are we taking the logarithm of? 64. What is that going to equal? The exponent x. And you're done. Okay, sometimes you might have a couple more steps. So let's write number 5 in logarithmic form. Now, number 5 has the square root symbol. So how are we going to actually transfer that into an exponent? So remember, this is going to be a 2. This is going to be an exponent of 1. So this is really 25 raised to the 1/2 power. So you first have to change this square root into an exponent. Then logarithmic form, log. All right, now what's your base? Because it's on the other side now. Remember, so this one was on the left side. Now we're on the right side. It's okay. Find your big number. Log base 25. It becomes your small number of x equals 1/2. You're still going around the circle, just like that. Okay, let's do this one. Find the value. So now they want a number. And so how we find a value, what I do is I turn this into an actual equation. So log base 3 of 9, I put equals x. And then I change to exponent form. Okay, so 1, I made an equation. And 2, I'm going to change to exponential form. So, all right, base 3 raised to the x power equals 9. Then I'm going to get same base and solve. What do I mean by same base? You did this previously. We have 3 to the x. Can I change 9 into having a base of 3? Well, yes. 3 squared is 9. So now that we have same base, we can cancel out the bases and we know x equals 2. Now, if you could just see this, if you're like, oh, 3 squared is 9, and so you know x equals 2, you can go there. You can automatically just write down x equals 2 if you know that. However, I'm just bringing in our past practice of actually changing to the same base just so that you don't forget how to do that. All right, next, find the value of log base 2 of 32. So 1, make an equation, equals x. Beautiful. 2, change to exponential form. Here's your base, 2. Raised to the x power equals 32. 3, same base and solve. So 2 to the x equals what number? 2 raised to what number? What number 2 times itself how many times? How many times do we need to multiply 2 by itself to get to 32? Let's check that out. Okay, so we can try 2 to the third. That's 8. Nope. 2 to the fourth, 16. Nope. Let's try it again. 2 to the fifth, 32. Perfect. So we know that 2 to the fifth, 5, is going to give us 32. So x equals 5. Now, let's say that you didn't want to go through exactly what I did, and you want to use your graphing calculator to help you find log base 2 of 32. You can do this. However, our graphing calculator, I said this in the beginning when we were describing logarithmic functions and graphs, my previous video, if you haven't watched it, you can. I said in the calculator, this log right here is base 10. So in the calculator, it's log 10. So we can't do log base 2 here. So what you have to do is you have to change this to calculator talk. You have to take it out of base 2. Very simple, everybody, to do that. First, you're going to write down log, and you're going to write down what we need to take the log of, the big number, 32, okay? And then you're going to divide it by the log of the actual base 2. So you're going to write log of the number that we're taking the logarithm of, and then 2 log of, that's your base right here. This one's always going to be in the denominator. And you're actually going to do that in the calculator. You're going to press log. Notice the parentheses come up and put 32, close them. Then I'm going to press the division symbol because this fraction bar is a division symbol. So I'm going to press the division symbol, and I'm going to push log again. I'm going to put my number 2 in, just like I have it here. And when I do that, I'm now taking it out of base 2, and I transformed it to base 10. I transformed it to this, from base 2 to base 10. You can always do it like this. You just have to remember that this number here, what we're taking the logarithm of, that goes in the numerator, and the log of the base always goes in the denominator. All right, let's press enter. Yay, we get 5. So here, x will equal 5. You could make this into an equation if you wanted, x equals 5. That's fine. Write down the x equals. But if you don't want to spend the day trying to figure out how many times we need to multiply 2 by itself to get 32, yes, you can take it out of base 2, turn it into base 10, use your calculator, you will always get the answer. We could have done that for this one too. Log base 3 of 9, so it'd be log of 9 over log of 3. That's what it would be, log of 9, the bigger than this number, divided by log of the base. So let's just try that real quick so I can show you. Log of 9 divided by log of 3. 2. Whoops, my bad. Log of 9 divided by log of 3. 2. Yay, it works. So yes, you can use this absolutely fine if you don't want to sit there and go through and try to figure out, how many times itself does it get us back to 9? How many times itself does it get us back to 32? So there you have it. Transforming between exponential, logarithmic, exponential, and using it to solve. Hope this helped.